There are two questions in this part. There are 3-point charges plus Q, minus Q, and plus Q again, placed at the vertices A, B, C of an equilateral triangle of side A. A plus Q, B minus Q, again C plus Q. Find magnitude and direction of net force on charge at A and B. So the net force experienced by charge at A and charge at B. This question is done as another video in the playlist. If needed, we'll just check at the end of the video after doing the second part. So we are doing the second part first. In the second part, there is no charge at D. The second part they are asking, another charge plus Q is now placed at the centroid of a triangle. What will be the force on the charge placed at the centroid? So this charge at D experience force due to A, B and C. D is positive charge, A also positive charge, so they mutually repel each other. A will tend to go backward, D will tend to go rightward, away. But our interest is D. We are not interested in the movement of A. Since we are finding the force on D, just check in which direction D is experiencing the force. Since D is repelled by A, D is supposed to go along AD, outward. So this is the force on D due to A. Same way D experiences a repulsive force due to C, because C and D are positive charge and our interest is force on D, not C. So check where D is supposed to go. C get repelled away from C, so this is the direction of force on D due to C. Now D experience another force due to the negative charge. Unlike charges will get attracted, so B will have an attraction towards D, D will have an attraction towards B. Still our interest is D, so D is tending to move upward. So the force on D due to B is in the upward direction, J cap. Now these three forces add up to give the total force on the charge at the centroid. Since force is a vector quantity, we are supposed to follow vector addition. So the force formula is K Q1 Q2 by R square. Q1 Q2 all are Q's only, the magnitude. Yet find the distance. When you find AD, CD and BD, all these distances are same. That's the distance from any one vertex to the centroid of the triangle. So AD, BD and CD, all the three are equal. For a triangle, the distance from any one vertex to the centroid will be side divided by root. That's a value to be by hearted. If not, you can learn how to find that distance also. How we find the distance of any one vertex to the centroid for a triangle. If this is a triangle with side A, the equilateral triangle, all sides are same, all these angles are 60 degree. You can learn the value by heart, but in case you forget, there is a method. So if you draw centroid, to get centroid, you have to draw the medians from any one angle bisecting that. That means each side will be 30, each side of the center will be 30 degrees. Like. Now this is the another one. So third one. We are not drawing the third one. Okay, fine. Third one. All these medians meet at this point. Now this angle is 30 degree. This side is half of the full length is A by 2. Now we are supposed to find A to D. So from triangle ADN, ADN, N is a right angle. So get cos 30. Cos 30. Cos theta is adjacent side by hypotenuse. AN by hypotenuse is AD. So AD will go here. Cos 30 is sin 60. Root 3 by 2. So root 3 by 2 into AD is equal to AN. So AN is actually A by 2. So root 3 by 2 AD is equal to AN, which is A by 2. The 2 to get cancelled, root 3 will go other side. So you get AD or BD or CD. All three are same as side by root. If you learn this value directly, then you don't want to find it. Otherwise, in case you forget, you can go and check how to find it later. So that's the side AB, AD, BD, CD all are A by root 3. Now, since the distances and charges are same, magnitudes of FDA, FDB, FDC all will be same. K, Q1 into Q2 both are Q by A square. A square means AD square, BD square, CD square, which will be A square by 3. So it will be K Q square divided by A square by 3, 3 will come up. So 3 K Q square by A square. A square by 3 will come up. That's a force on charge at centroid due to each A, B and C separately. Now you have to find the total. When you add vectors, you have to be careful. There are certain rules to make it easy. We learn that first. If F1, F2 are two forces with theta as the angle between the two, then the resultant force is given by root of F1 square plus F2 square plus 2F1 F2 cos theta. This to be applied only if the two vectors are not parallel, not anti-parallel. If they are parallel, nothing to do like this. You can just add the magnitude, put the same direction. If they are anti-parallel, opposite, just subtract greater magnitude minus smaller magnitude and put the direction of the greater one. Any other angle other than 0 and 180 degree, parallel and anti-parallel, you must use this particular formula for finding the resultant. Now, in this case, two vectors are equal. Any case, if two vectors are equal, these are the vectors A and B or F1 and F2. And theta is the angle between the two vectors. In case if F1 and F2 are equal, the resultant will be always along the bisector of F1 and F2, the angle between F1 and F2. So if the two vectors are equal, the resultant vector acts along the line bisecting the angle between F1 and F2 in this particular, it will be along this particular line. Now we have some special cases like if F1 and F2 are equal and the angle is 0 degree. If F1 and F2 are equal, angle is 0 degree, nothing to do vector addition, you can just add both. It will be simply F1 plus F2 since both are equal to F1. Or you can apply here, this will be F1, this also will be F1, F1 square, 2F1 square and cos theta cos 0 1. So 2F1 square, 4F1 square, root of 4F1 square is 2F1. Nothing to do, go for this equation. If two vectors are equal and angle is 0, it will be just double of that. Or if angle is 0, always you can simply add vectors. Now if the two vectors act at 60 degree and they are equal, F1 and F2 are equal and theta 60 degree. So F1 square, F2 also will be F1 square, 2 F1 F2 both are F1 F1 square, cos 60 is sin 30 half. So half and 2 get cancelled. So F1 square, F1 square, F1 square, 3 F1 square, F1 will come outside. So root 3 times of F1. So if two vectors are equal, the angle between them is 60 degree, the resultant will be along the bisector of F1 and F2 whose magnitude is root 3 times of one of the two vectors. Now if they are 90 degree and equal, if 90 degree, cos 90 will be 0. This full term will go 0. So f1 square plus this also will be f1 square. 2f1 square, f1 will come out. So root 2 times of f1. Now the third case, if they are 120 degree, if the two vectors are 120 degree, so cos 120 is minus 1 by 2. So 1 by 2, 2 will go minus. So f1 square plus f1 square minus f1 square. So 1 f1 square get cancelled, just 1 f1 square totally will come. So root of f1 square will be just f1. This is an important result. If two vectors are equal in magnitude and the angle between them is 120 degree, the resultant vector also will be same as the first vector in magnitude. The direction will be always along the bisector of the two vectors. No one will expect 10 Newton plus 10 Newton will give you 10 Newton. Resultant. The 10 Newton acting at 120 degree with another 10 Newton can give you resultant also 10 Newton. So important result. Now if the two vectors are acting 180 degree opposite, so nothing to do, you can just subtract. Subtracting, if they are equal, will be 0. When you can apply here, cos 180 is minus 1. So f1 square plus f1 square, 2f1 square minus 2f1 square will be 0. So these are important results to add vectors at different angles. Now here if you check FDA and FDC are equal and the angle between them is 120 degree. For an equilateral triangle this is 60 degree. All these are 60 degree. So if you find correspondingly these three lines, the opposite lines, FDA line, FDC line, if you draw one line down, that divides the total 360 degree into three equal divisions, FDA, FDC, and if you draw one line down, that divide the total 360 degree into equal divisions. So each one will be 120 degree. So FDC and FD are equal and they are 120 degree. So equal and 120 degree we have a result here. Like 180 degree we can write first. Is 180 degree. If two vectors are equal and the angle is 120, the resultant is same as magnitude of the one vector itself. That means when you add FDA and FDC, since they are equal and the angle is 120 degree, the resultant will be again 3kq square by a square along the line bisecting those two vectors. Be along D to B, means along JK. Now this resultant of FDC and FDA to be added with FDB. FDB also 3kq square by a square which act along JK. So FDA plus FDC is along JK. FDB is also along JK. If two vectors are in same direction, simply add. So 3kq square by a square JK is FDA plus FDC. Even FDB also will be 3kq square by a square. So total will be 6kq square by a square. So that's a net force on the particle at D. Now if you want to go back to the beginning, the second part is done. Force on A. Here A will experience force due to B and force due to C. So B will be attracting A. B attract A like this. Now even A is repelled by C. So these are the two forces acting on A. So this angle is 60 degree. So this linear pair, so this angle will be 120 degree. This force is K, Q into Q square, the side is A, KQ square by A square. Even this force also magnitude wise KQ square by A square. So FAC, FAB, both are equal and the angle is 120 degree. So the resultant is also kq square by s square, which will be along the line bisecting these 60 degrees. So that's a resultant force on A. Now if you want to find resultant force on B, B is a negative charge. B is attracted by A down like this. B is attracted by C also down like this. The magnitudes are, charges are Q, distance is A, same charge and magnitude. So kq square by A square, kq square by S square. So FBA, FBC both are equal in magnitude and the angle is 60 degree. For 60 degree, the resultant will be root 3 times of one of the force. The resultant force will be along the bisector, which is downward minus j cap. This is equal to root 3 times of one of the force. One of the force is kq square by s square. So be root 3 times of kq square by s square. So if you understood, mathematically speaking, force on A due to C equal to force on A due to B magnitude wise, they are k q square by s square, and the theta between them is 120. So the resultant force on A will be applying the same condition, it will be same as one of the force. That means k q square by s square itself, but along the line bisecting this repulsion, this attraction. So this will be the resultant force F, which makes 60 degrees both. Now the force on B due to A will be same as force on B due to C magnitude wise, that is again kq square by s square. But here B is attracted towards both. These two forces are equal and the angle between them is 60 degree. So the resultant force for 60 degree case is root 3 times of F. So force on B equal to root 3 times of k q square by s square, that is along the line bisecting force, that means along minus j. So already done as a separate video. You need to check that.